Um, yeah, so hi everyone. Um, Advent of code again. Let me just switch my screens. Yeah, okay, good. Right, so day 3. Gear ratios. You and the elf eventually reach a gondola lift station. He says the gondola lift will take you up to the water source. This is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They're not moving. Ah! You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still sorry, can't speak today. It'll still be a while until before I can fix it. He offered to help. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. The engine schematic, your puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Periods do not count as symbols. It's an engine schematic. In the schematic, two numbers are not part numbers because they are not adjacent to a symbol, 114 and 58. Every other number is adjacent to a symbol and so is a part number. And sum is something. Of course, the actual engine schematic is much larger. What's the sum of all of the part numbers in the engine schematic? Okay, so I've thought about this one. The thing is, it seems like you'd need like a 2D array, or like, I don't know if a 2D array is a great idea because it's kind of massive, right? Yeah, probably wouldn't want a 2D array for that, but like, you'd need something two-dimensional. But I don't think you do. I think you can do this in one pass. Um, it's gonna be a bit tricky, but I think you just need one, like, technically dynamic, but I guess you could just use like 4,000 bytes should be enough, right? Like we can have one, or like two buffers, I guess. Like one behind our current lines. If we are here, for example, we just remember all the symbols that came on the line before, right? We remember this one and this one and this one and so on. And then we just, whenever we find a number, we check one case if it's, or actually we have a few cases. We either have a symbol directly before the number, like in this case, that's the easy part, or immediately after, that's also easy. Or we need to check if it's on the line before, or if it's on the line after. And if it's on the line after, that's a bit tricky because we haven't read that one yet. So what we actually need to do is that we remember the number and then check on the next line if we find a symbol, if there was a number above, and if there was, we remember that one. So yeah, lots of keeping track of stuff across lines. I'm pretty sure part 2 is gonna be pretty difficult, so we might not be able to do that one today. But we'll see. Okay, let me switch my screens back. Oh, and also, I have noticed something. Like, we've been using, what was it? Yeah, actually, just that. Uh, we've been using this rechar function, and I've noticed that all the solutions were kind of slow. Like here I can demonstrate, I think, in like day 2, if we just, or actually day 1, um, if we just like run the Haskell solution for part 2, that one takes like what? Like, okay, let's run GHC. If we compile that one, then run it, that takes like what, 20 milliseconds? Um, uh, and if we do the same one in our assembly solution, but yeah, then it takes what, 38 milliseconds? It takes longer than the Haskell solution, even though that one allocates like tons of lists and like a lazy stream of suffixes for everything. I don't know why, because we've been using this buffered reader thing where that like we read into this input buffer and then we just read one character out and we refill it if it's done. Yeah, we haven't actually been doing that. We've just been reading one character at a time every time. So, yeah, that, whoops. That explains why it's so slow. And so I'd actually like to just, I don't know, take like part two of this one and just fix that one quickly before we start with the new one. Because I think it's going to be easier to debug if we choose one that's already working. Let's try that. If we do not part two, but part two, it's not use a space there. So if we do this, I think, yeah, that should work. And if we just do input, whoops, I don't mean to do that. If we just do input buffer capacity, then that one should work, but it might not, because I might have messed, yeah, because I messed something up. Yeah, because I don't think this refill thing actually quite works correctly. But why? Why does it not? Oh, wait. Okay. Oh, because we don't want input buffer capacity. We want what is 4096? Yeah, because that one's 0 initially. Right. So we do 4096, and it's still not working. Why's that not working? What if you do like 2? No. Okay. Yeah, it's fire up GDB and break the char. Okay, so that one, wait, what's happening here? 15 is currently 0, right? Yeah, and input buffer capacity should also be 0. So, whoops, what happened there? Wait, what? What did I do? Oh, I did next, not next, yeah. I did next, not next instruction, that's why. Right, so we're comparing, and yeah, JL does not fire, because it's, yeah. We are at 0, but also our capacity is 0, so we just refill it by moving file descriptor. I think it's the input buffer and RDX, right? And we are gonna read up to 2 characters for now, because it's easier to test, I think. And then we're doing a syscall, and that returns 2. Yeah, that's good. So we did not reach our end of file yet, and so we're just saving our capacity and resetting the buffer. And yeah, resetting the buffer. Yeah, that's correct. We're resetting the buffer next, which doesn't actually do anything because it was already 0, because we haven't read anything yet, obviously. Then we read, increment, and return. Yeah, that worked perfectly, I think. Did it? Wait, did it? Oh, no, wait. Did that one just... Wait, why is there this number in RX? Hello. I wouldn't call myself an assembly god after after last stream. It's fun. Okay, like so right now we're fixing this buffered reader function because I wrote this one last stream and we already used it for day 1 and 2. But I actually just had the capacity set to 1, so it was reading 1 byte. So it was doing 1 syscall per byte, which is so yeah, that actually made it slower than like the Haskell solution that uses like a lazy list of string prefixes, string suffixes. So and like tons of allocations. So yeah, we're fixing that one right now. And I have broken something. I'm not entirely sure what. So let's go through this again. Okay, so that's all working. And now it's reading from the buffer, and that's completely wrong. Why is that? Oh, because no, I'm not. What? Why is that completely wrong? What's that about? I started learning assembly, but I couldn't find something that's good. Yeah, it's kind of, I don't know. I don't know any good resources for assembly either. It's just like just write some assembly. I guess Advent of Code is really nice for this because you can just like okay, day one was relatively difficult, but if you do day two, that one wasn't too bad. You can just kind of write something down and like you have something comparatively easy, um, like and self-contained that you can just kind of try. Um, but yeah, I don't know any good resources either, unfortunately. Yeah, okay, so let's look at our input buffer. Hex 6147. Wait, um what is 61, that's an A. 47, that's a G. Wait, what's our input? G. Yeah, that's G and A. Wait, so I am reading the first characters correctly. Oh, I know what I'm doing. Of course. I don't want to move the entire IX, I just want to move one byte. Right, and now it's working. Yep, and now I can probably do 4096 here, and it's just gonna work. Okay, no. Okay, I can't do that part. Um, okay. Let's try something. What if we do like 10? Only found videos about solving crack me videos. That's it. Okay. Yeah. Yeah, so again, just, I don't know, just try something. Just write some assembly. You figure it out eventually, honestly. If we do 100, 100 works. What if we do 1,000? No. What's the limit? 50 still works. Wait, I need a calculator. 50, 375. Okay, that one's not working. This is maybe past 256. Yeah. Why is that? Wait, why does it hang if we pass 256? Why is that? What's our wait? Our input buffer is 4069 bytes. Yeah, that's good. Why does what? Why? I'm so confused. So first iteration, access call, whatever, and returns. Yeah. Next iteration should skip the refill and read into IX, and that's wrong. Wait, doesn't this reading into AL not clear the upper bits of IX? I thought it did. Does it not? Wait, does it really not? Wait, if we do, let me just try something. If we do like move IX -1, and then we do move AL like 1 byte. Oops. Does that? Wait, no, IX is hex FFF. And now, oh, it doesn't. I always thought it would clear the other bits. Okay, then that's easy to fix. Huh. Oh, and that explains why it breaks once we pass 1 byte, because yeah, then it keeps the earlier bits in IX. Like then it our length is more than 1 byte, I guess. Yeah. Yeah, right. And then this IX is like more than 1 byte, so we have like I don't know how much of zeros, then like 1, 0, 0, 0, 1, right? Something like that. Actually, like a bunch of zeros. Yeah, we have like this, and that's our byte boundary, right? And so this one just moves into those. like most of the characters, so it's like, I don't know, something, I don't know what that is, but yeah, move something into lower 8 bits, but this one stays there, so the result is just completely wrong. Okay, that explains that, so we need to zero out X. And that works, perfect. And that one should hopefully work for 2098 bits as well, yeah. And now we're down from, what, 40 milliseconds to 1. Perfect. Okay, cool. Let's copy that one. And let's actually start with day 3. Okay. So we are gonna copy over read char, and we're gonna need read number again, and print number. And I think that's it. Yeah, that's it. Okay. Oh, and of course, corresponding data. So we're gonna need those, but not totally some. Okay, cool. So let's get rid of this. Okay, right. So okay. So we have our underscore start. Oh, and I forgot the initialization, of course, because there's we're gonna start here. Because we need the initialization part from here. Okay, so day 3. So what are we gonna do? We need like one array that it's our previous. So we need our set of previous. Wait, I'm to get the input so I can actually show you what I mean. So I can point at what I mean, I guess. So we have our input here. We need one array where we remember the symbols on a previous line. So like if we come across this 511, we need to remember that star so that we can, like when we pass the 5, we can see that there was a star, so this one is valid. Right? Yeah, okay, so we need that. So we need previous symbols. It's an array of, I guess we just need like booleans, but that's gonna be kind of, let's do quad words, because that's kind of inefficient. Like we have 4 bytes per, no, 8 bytes per just boolean, pretty much. Actually, no, we don't. Never mind. We're not gonna store every byte like that, because that's, I guess we could. No, but that's annoying. We can just store the positions and then iterate through those. I think that's, maybe not. No, there are 141 columns. I guess we can just have like a bit set or byte set, because bits are annoying. How do we want to do that? Do we want to do a bit set, which is technically faster, or an array, which is technically more extensible? So we could technically have something wider and wouldn't need to hard code the width. No, let's do a bit set. Let's do a bit set. Yeah, let's do a bit set. So we have like, let's do 150 just to be sure. Actually, no, we can hard code the length. No, it's 141. Yeah, so it's 141 bytes. Although we do need to zero those out. Oops, sorry. We do need to zero those out once we pass 1, which I think that's not an issue. And those are times 141, 0. Those are our previous symbols, and now we need our current, or actually last number. Oh, no. We need to do that differently. We need our previous symbols, we need our current symbols. Because we don't need to, we actually don't want to zero those out. Like the symbol, okay, of course, the first line doesn't have a symbol. We don't want to zero the ones out we found here, but we want to replace them by the ones we found on this line. Right? Yeah. So we want to copy those over and at the same time clear our current symbols. Okay, so that's also 141 zeros initially. And then we want to do current numbers. Oh, and current numbers can't be something like that. Because if we do keep track of the numbers per line, we need to remember the exact number. Ah, that's kind of... how do we do that? I guess we can do like a range. We can do like this 919, and we remember that this one starts at position, what's that? Like 7? And ends at position 9, right? And then we, like for every symbol we find, we check everyone in the previous line. For every number in the previous line, we check if it's in this range. Well, actually, if this one is in the range. Yeah, I think that's okay. Right, so we do, so what is that? So let's do like 100, yeah, let's do 141 because we're not going to need more than that. Okay, actually, let's do, wait, so we are, wait, okay, so current numbers is effectively going to be like an array of, like tuples of quad word, and of, I guess, start, end, and the actual number. Right, so we need 3 quad words. We need 3 times that. Doesn't allow that. Oops, wrong. No, the wrong one. Whoops, it's not called part 3, it's day 3. It's called part 1. It does not, what? Kind of? Oh, that's times 141, 0. Yeah, it does. Okay, cool. Why did can find, what? Can it find input symbol start? What? Is that this one doing that? No. What's that about? What did I break? This one's doing underscore start. And this one's also underscore start. That's strange. Why? What? What's happening? What's it called? Update dump. How do you find symbols? I guess we can check the source that update dump gives us. Yeah, there is an underscore start. Why does it say it can find a symbol underscore start? How did I even break that? Oh, I know what I did. That's not here. I need bits and a global at the top. Because NASM is being NASM. I need to tell it that we are working in 64 bits and that start is a global somehow. Not entirely sure what that means, but it's necessary. Yeah, okay, and it should say false. That's correct. Because I don't have the exit. Let's exit. Yeah, let's exit. I mean, it's just 60 and 0, but actually could have done that. But yeah, I don't want to have to debug things like that. Let's just copy that. Okay, so we have like basically an array of start, end, and numbers. And that's our current numbers, and we also need previous numbers. That's the same kind of array. So that's also three, yeah, start, end, number indices. Okay, and we need to, so on one iteration, we need to do what? We need to find all the symbols, find all the numbers. If we find a number, check that or if we find a symbol, check if there was a number on the previous line, or if there's a number coming after it. And if we find a number, check if there was a symbol on the previous line, or if there's a symbol after it. Okay. And well, diagonals shouldn't be any more difficult, I think. Yeah. I don't think diagonals are any more difficult. Okay, so yeah, and I guess that's just one massive loop then. And does all of that. Okay. So we're gonna read one character. And what are we gonna do? So we have one character, and now we're gonna. Oh, actually, what kind of charts are allowed as symbols? Everything other than numbers and periods, I guess. I guess doesn't actually say that. Okay. So we're gonna compare that to actually no. First of all, we need to increment, or we need a an index. Let's use R14 because that one should be pretty fast. So we designate R14 as our register for our column index. So we'll read one character and then we'll increment R14. Actually, should we? No, we should increment R14 afterwards, I think. Yeah. So before we jump back, yes, we started index 0 and then read one character and then the next one is at index 1 and so on. Yeah, okay. So, right. So we have one character and we can see if that one is a dot. Actually, this doesn't support that. Yeah, I think it does. It's just running an infinite loop because that's an infinite loop. Okay, so actually, one is if it's 0, and let's worry about that one later. If it's 0, we'll jump to on your F, and let's do it later. Actually, that one just can just exit, I guess. That one should already, yeah, should finish. Also, if it's a new line, we'll worry about that one later. And otherwise, if it's yeah, if it's if it's that, we jump to a new line, and if we've hit a dot, we'll jump to loop end, because yeah, we hit one dot, we don't actually need to do any interesting processing, I think, right? Yeah, if we're here, there is nothing interesting to do. Like we know it's, well, actually we should maybe do like a state machine thing there, but like if we hit a dot, we know there's, that doesn't actually give us any information unless we were previously passing a number, I guess. But that one's probably gonna be a special case, hopefully, maybe. So yeah, we'll see. But yeah, I think we can just skip that one. And otherwise, it can still be a number, and if it's less than 0, then it's gonna be number. So if it's less than 0, it's an ASCII boolean, it's going to be a symbol, and if it's greater than 9, it's also a symbol. Greater than 0, greater than 9. It can't type today. Greater than 9 is a symbol, right? And otherwise, it's a number. So we can subtract by digit. We can subtract 0 from it and get the digit value. Hello. Yeah, I've done the last 2 days in assembly as well. This was fun. Yeah, day 3 is pretty difficult because there's like if we do this one in one pass, there's so much we need to keep track of. We need to remember the numbers on previous lines, we need to remember the symbols on previous lines, and well, I guess that's everything we need to remember, but like we have so many cases, we need to remember that there's a star here, and we also need to check if there was a number previously, like this one. And so on. And yeah, it's kind of a lot. I'm probably not going to be able to do FAT2 today, which we'll see. Right. Okay, so Ix is a digit, and that means we need to keep reading. What does that mean for us? That means we wait. So we have hit this case, and that means we need to remember that it's a number, and we need to check if there was a symbol before on any adjacent thing, right? So if we are here, this 9, we need to check this one, we need to check this one, and this one. Okay, but I don't think that's that bad. We have a digit value. Okay. I guess I'm trying to decide if we should use this loop, like if we should reuse this loop and add like a stage machine thingy. If we're in a number, if we should do its own loop, but then we also need to keep track on the column index and things like that. Yeah, I think we should do its own loop. So yeah, let's try that. Reach number loop. And right, what are we gonna do? So we know Ix is a number. And that means we need to compare, I guess what previous symbols minus 1. Oh shit, that's kind of an issue. If the first one we ever pass is a number, we need to check here. And that's problematic. Actually, you know what? We can avoid that. We can just, that's a really stupid solution to that. Yeah, let's do that. Okay, we can just start our indices at 1. If we just say this one's 1, then the array before that is always going to be 0. Yeah, let's do that. Okay. So we can, yeah, we'll just increment R14 immediately. And write a comment for that, because I'm absolutely going to forget about that otherwise. Increment R14 immediately. That our indices are 1 based. And we can read from the character before the first, or actually we can reach 1 before the first character. Right. Okay, right. So we increment R14 immediately instead of at the end here. And so yeah, so we have our 1 based indices. And it's gonna make things a bit easier. And actually let's not do 141, let's do like 200 for good measure. Is loop functionality the same as a conditional jump? What do you mean by loop functionality? Like this loop is not, that's just a name, that's just a label. Like this is just doing a jump. Then conditional jumps are jumping out of that one. Yeah, it's just x86. So this is, yeah. Not the easiest assembly maybe, but the one I know. So, you know. GPA 1 characters. I had this is 200 for the letter. Okay. Right. So we read. Right. So we are reading numbers. We need to check the one before. So if what's that one? Previous symbols. Previous symbols plus are 14 minus 1. I think I can do that. If that one is a 1, then what? Actually, how does test work again? Let me look that one up. Test from the bitwise and on 2 operands. And that's how you do like equal, right? I don't know. No, let's just use compare. I don't know. I think if we use test there, that would be more efficient, but I don't want to risk that right now. Let's just compare. Right, so if there is... Actually, we can do a conditional move, I think, to save some branches there. Wait, so if the earlier one, or this one, or the next one. Yeah, so we'll just use RBX, and we'll stream of equals x1. So if that one's 1, we'll set RBX1, and if the one immediately above is 1, we'll set RBX1, and also if the one ahead is 1, let's set RBX1. Okay. Right, so we have checked all of those. Actually, I don't even know what we're gonna do with RBX is 1 right now. Right. We can't persist RBX between loops because RBX is not Corley saved. Corley saved? Yeah, Corley saved. I always mix those up. So if we do another read, that syscall might modify RBX. But that's fine. Okay. So we'll just, yeah, I guess, let's not use RBX. Let's, actually, yeah, let's use like R13 for is valid, or is a what did they call it in the thing? Is a valid part number, I guess. Yeah, is a part number. Okay. So as 13 is if we know this one is a part number, and then what? Yeah. Okay. So we do. Oh, actually, we don't want to do that one. We want to compare 13 RBX, and if no wait, if actually we want to compare RBX and 1, and only if it's a 1 we want to set 13. Actually, no, we can just use R13 here. We don't need to do that. And we don't want to clear it. We want to do that when we first set a number, I guess. Yeah, I think so. So, yeah, we need to do this one a bit differently. Right, so Ix is a digit. So we'll XOR R13 R13. Let's say 13 is a part number, right? And this one is 0 because we don't know that yet. Right, and if we ever find one that was preceded by a symbol on the previous line, then that one is definitely a part number. And then we just keep reading, I guess. So we let's add on the make it any of the JSON characters. Oh god, I can't type today. The previous line are symbols. It doesn't really matter for this part if this one found anything. Oh, actually, and we need to use, let's say, R12 for our number we're passing right now. Fortunately, passing numbers is pretty straightforward. But you just like multiply that one by 10 and then add the digit. And then we have added one, like appended one character at the end. Or one digit at the end, I guess. Right, so we read one character and oh no, we don't. Oh, that's annoying. We need to do all these checks again. We want to do this in its own loop. Yeah, but I think we should do that. Okay, so we compare all of those. Yeah, because we need to do like several things there. Yeah, okay. So let's let's do all these checks, but on number EF, on number new line, and I don't even know. And that one is number symbol. Okay, this one is a new digit. And so I guess if we're here, we can increment R14 and jump back to the loop. Oh no, we can't. We actually wait, no, I did this one incorrectly. Because R12 shouldn't be 0, R12 should be IX. Because we already have one digit, right? And so, right, if we're here, we've read one additional digit. So we'll multiply what did I use? R12, right? Yeah, R12 by 10, and then add IX by 5. And then jump back, right, and read the next character. Or start reading the next character. Yeah, we do want to increment afterwards, I think. That's fine, hopefully. Because we incremented earlier here, but I think that's okay. Yeah. Okay. So that one and digit etc. What to last number. Okay, so we have added, we can add digits, right? So if we are reading a number, we are passing the entire number. Now what if we are, okay, so the interesting bit is now if we hit something that's not a number. So if we hit a non-symbol, actually I think we can do something kind of nice here. We can just do non-symbol, actually number non-symbol, and we can have a number symbol. And the only difference between those is that in the number symbol we so for one right, this one is hit a symbol after missing a number. We just move 13 1 because we know we have this one is a valid part number because it's like the character after it is a symbol. And also we need to remember this symbol. So that means move. Wait, have we incremented? Actually, no, I did this one incorrectly. we need to increment before calling the char. Yeah. Yeah. That's how we did it up here. Yeah, okay. We just jump back afterwards. Okay. So we need to, so R14 is our current symbol we just read. So we need to set current symbols plus 13, and actually move that as a byte. You just set that to 1. Yeah. Okay. Let's do those as bytes as well, just to be sure. Yeah. Oh god. Okay, let's do that one second. Okay, so we remember the symbol, and we set this to having hit a symbol, and then the logic for hitting a symbol and not hitting a symbol is the same because we need to check R13 anyway. Yeah, okay. So then we do what? We actually I forgot something. We need to remember the count here. Yeah. Okay, so we need to add our number as a like into this array. We need to remember the start, end, and the number itself. So we need to. Oh, actually, wait. We didn't save the start location. We need to do that. So I guess we need to into. I don't know if add10 is quite safe. So let's use a static variable. Just yeah. Initial number position. Doesn't matter what it starts off as. Where are we? Where are we? Here. Yeah. Okay. Move initial number position. R14. Right. That's the first one. Actually, I think we should. Yeah, we should probably move that from -1. Number current position -1 because of we need to check diagonals as well. And that's gonna make things easier, I think. Because then we don't need to do the -1 when checking. Right, so that's our initial number position. And now we need to, what did I do? Initial and then the number. Yeah, okay. So we move into, what's it called? Current numbers. That's actually current numbers count. I don't want to store the count there. I want to store the offset, I guess. Because we need to increment that one by 3 every time. Right, because we have 3 keywords. Because it's like an unboxed tuple, pretty much. Excuse me. Okay, so we have current numbers plus actually, wait, no, move VX current number offset, and then plus RBX like into the first location we're gonna move the initial number position. I don't know if this move works, but we'll see. It's a keyword, and we move into current numbers plus RBX plus 8. So the next keyword, we'll move the end position, so that's R14. Yeah, and that's already one past, because we are already one character past the last one. That's the number. Okay. And then we need the number itself, obviously. Okay. So plus RBX plus 16. That's what's the number? Where did we save the number? In R12, yeah. Okay, so yeah, we remember the start position and the end position and the number itself. Okay. Okay, so we have remembered the number, and we have checked for symbols above, and we have checked for symbols after. And now I guess we need the logic for checking for symbols before and for checking for symbols in the next line. Yeah, so the actual symbol logic. That one's easier though, because we don't need like an individual loop, I think. Oh, do we? We might. Doing this in Asm. Yeah. Yeah, that's, this time is kind of difficult because we can't use like I guess we could use like 2D data structure, but that's annoying. And I don't want to do that. I want to do this in one pass. So we are, like the way we're doing it is, sorry, we remember all the, so say we are on this line right now, or actually it's just this one line, then we remember all the symbols on the previous line, right? Because, like, just to recap, the task is that we need to save all the numbers that are adjacent to a symbol, right? So that means across diagonals, if there's a symbol in the next line, current line, or previous line, then this one is a valid part number, and we need to remember that one. So what we're doing is if we're on this line, we look at all the symbols in the previous line, and like if we pass a number, we check all the diagonals. And if we find one, we know this one is a valid part number. We just keep passing it. And also in the other cases, there could be a symbol before the number, like in this case. Or there could be a symbol after the number, like in this case. But those are comparatively easy. And also we can't check in the next line. That's the difficult part, right? So we need to remember the numbers as well. And once we hit a symbol in the next line, we check the numbers that came before and check if anyone is in this range. And if it is, we like retroactively remember that one and remove it from the array. Oh, I just realized that. Yeah, we can do that by just setting the start and end to 0. That's okay. Like if we have something like, does that appear anywhere? There are two symbols that hit the same number. Can't see one right now. But if we have like this, right? No, it's like this, right? And hello. Then we have like one symbol here and one symbol here. And once we hit this one, we need to remember to unset that number and remove that from our array. Pretty much. Oh, actually, that just reminds me that means we might have just made a mistake there. So we need to remove that one so we don't count it twice. But wait, how did we do that? Yeah, okay, we don't want to do that one in the case where we hit a symbol. I think, right? Yeah, no, we don't want to do that one. We actually want to jump to the want to jump past the non-symbol part. So it's actually the opposite. If there's a non-symbol, or if there is a valid number, I guess, or part number, I guess. And yeah, and in this case we'll compare a 13 and see if this one was a valid part number. So if this one was a valid part number, we treat it as if we hit a symbol. Wait, but did we? Oh no, we can't do that one either. Because if we hit a symbol, we still need to remember that symbol for the next line, right? Yeah. Okay. I guess number symbol. Yeah, doing this one just doesn't seem that much more complicated than doing C without standard. I mean, yeah, kind of. It's a bit more because it's like you wouldn't want to like traverse like binary trees like this. But it's the main limitation is actually you don't have a standard lib. Yeah, the main limitation isn't even the assembly. Um, yeah. Okay, so there's a number symbol, and wait. So wait, where was I just lost my train of thought? Right. So if we have a symbol, let's just start there. Then we need to remember that we hit one. So current symbols plus what's the one? 14. That one to one. Yes, go to the first trees already. Okay. Go to's ideally for trees. Okay. I guess that's what you have to do if you don't have tail recursion. Yeah, okay. Right, so we wait, so we have the symbol. So number I don't use standard codes, no. I'm doing everything myself. Because otherwise it's pretty much just like less ergonomic C if you're allowed to use like libc calls. That's boring. Remember that we just move them on the next line and then what? Then what? We don't want to do that. Actually, I guess we can just merge those, right? Just remember that one and we move 13 1. And then if there's a symbol or non-symbol, it doesn't really matter. We like either save the number position if if it is not necessarily a valid part number. Otherwise, we don't need to care about it. And so if we have it, we know is already a part number, and we need to jump out here. I'm not sure where to jump. I guess back to the main loop. Yeah, I guess we jump back to the main loop. And if it is already a part number, we add to our total sum. If we know this one is a part number, we add what's the number? R12 to our total sum. And jump back. And we don't need to remember anything else because we because we already know this one's part number, so it can't come up again. Yeah, okay. Right, so that's everything after passing a number. And now we just need new line handling, end of file handling, and actually hitting a symbol before passing a number. Right. Okay, so if we hit a symbol before passing a number, then what? I guess we also need to dispatch on the next character. Yeah, I guess we wait, so first of all we need to remember the symbol for the next line. Remove symbols. Oh, actually, I made a mistake there. I just realized. We also need to add current numbers offset 3. Right. We need to like increment the length of our basically dynamic array, more or less. Kind of. It's not dynamic because we're not doing dynamic memory allocation, but you know. Okay. So we current symbols plus R14 because that's our current position. That's gonna be 1. And then what? So we remember that this one is a number, and then we check the next character, I guess. And we set R13 to 1, I think. and then jump like in between here, like between those. Oh, that's kind of messy. Start reading number, I guess. Yeah, sure. Let's do that one. And yes, that, and then jump into start reading number, but only if necessary. So we compare. No, we increment our 14, and we read the next character, and then we dispatch on that one. And the question is if that one is a 0, we jump to symbol EOF. I don't know what to do there yet. I guess that's just like a regular end of file. Let's do that and see if it breaks. And if we hit a new line, I think that's just actually wait, I forgot something. We need to check the previous line as well before we increment. Okay, so before we do this, next character. Before we do this, we need to check for numbers on the previous line. And to do that, we need to loop through our array. That's a previous number loop. Right, so I guess we check the start position. Wait, do we care about IX? No, we don't. We have used IX already. Yeah, we only care about the symbol. So I guess but let's still use RBX because. So we keep the. No, that's annoying. Okay, let's use IX as our loop counter. Let's do a standard, super boring for loop. The IX is already at the end, so that's initial number position. No, actually, that's previous numbers offset. It is there, so that's greater or equal. Then we jump out. And otherwise, we keep doing stuff. And we add x3 at the end. Hello. Been using Haskell on and off and can get by as far as mono transformers and MTL. Okay, that's cool. Would like the mathematical understanding of category theory or the surrounding topics. Is there any specific resource that you would recommend to help you help that out? Oh geez. Okay. Right. So, okay, first of all, you don't need category theory. Like, you can get into category theory if you want, and it's cool, but you really don't need to. Like, I don't know pretty much any category theory. But the thing is, if you want to do type theory, that's probably more useful. And I think it's kind of hard to recommend things. Let me just think. Okay, so if you want to do into like mathematics behind like type theory and things like that, I can recommend types and programming languages. Like I haven't read it, but I've heard a ton of nice things about it by peers. And there's also like programming language foundations if you want to get into semantics. And personally, if you want to get into like really type theory, just read papers. Just read something you're interested in. I really like this. Wait, let me find it. Yeah, I really like this paper personally. That's probably my favorite paper ever. About like GHC's type inference and bidirectional type inference and higher rank polymorphism. It seems more complicated than it is, but it's really it's quite nice. It's like goes into small steps and starts from like very standard in Limilna and builds up into higher rank polymorphism and bidirectional typing and things like that. Um, and it has a full implementation in Haskell. So if you know MTL, you should be able to follow it. That's really nice. And yeah, so just sorry, so just yeah, just read things. I don't really have a better recommendation than that. But yeah, just read something you're interested in. That's the main one. Like if you like types, just read about types. If you like, I don't know, what else to say? Like, if you like category theory, just read about category theory. That one's kind of hard to get into, but I think you'll find something. And like, for some of the things, I think Edward Kmet has a few really nice talks about, like the category theory behind lenses and things like that. So I don't have them in my bookmarks or anything. So, but yeah, if you just look for some Edward Kmet talks, they're pretty much all fantastic anyway, even if they're not about category theory. So I'm sure you'll find something. Okay, right. Back to our parsing thingy. Right. Okay. So if right, we are looping through our previous numbers under the previous line. Yeah, you're welcome. So if we are looping through our previous numbers, and so we need to move the start position. So yeah, it's our start position. Actually, that's our start of our range, and that one's already offset by 1 to account for the diagonals. And that one's where's that? That one is previous numbers plus Ix, yeah, that one, and RCX is the same one, but also plus 8. 8 because it's an 8-bit number, right? A keyword. So RCX is the end of our range. And do we? I guess we don't, yeah, we don't need to move the number itself out yet. We only know that if we are inside the range, I think. So yeah, so now let's compare RBX, start of our range. Actually, we don't even need to move anything, I think. We can just compare inline, right? We can compare R14, so it's our current position for either of those. And if we are less than the range, less than the start, we can skip this one. So if we are JL, then let's skip number, I guess. And if we are greater than the end index, yeah, then we can skip this number. And otherwise, number is valid. So we can move into RDX previous numbers plus x plus 16. I just realized, where did we remember? Did we add our number to our total? Even? Did we do that? Oh, we did. Yeah, okay. So we just need to do that again. Where were we? Yeah, okay. Wait, no, that's not. Wait, where? God, I'm losing track of where we were already. Here, previous number loop. Right here. Okay, this number is valid, so we move that one to RDX and then add to total sum. Although, can you do an add between two memory locations? I don't think you can. Pretty sure you can. So we need to go through RDX, and that's a keyword, so that's fine. We don't need to go through bytes or anything. Which I absolutely messed up already. That needs to be a byte. Okay, so this number is valid. So we move it, and we also need to reset bounds, so we don't count it twice. It's still gonna take up space in the array, but that's fine. We don't really care. That's previous number. That's ix is gonna be 0, and that's ix plus 8 is also gonna be 0, and we don't need to reset the number itself because we don't care. And then and that's the same as here. We just keep doing. No, actually, oh yeah, no, we need to go through all numbers because we could have something like these two, and then have it symbol here, and then both of those would be valid because of this star. So yeah, okay. So we need to look through all numbers. We can't break here pretty much. Yeah, okay. That's what we're doing there, and then. Are we ever jumping? Yeah, we are. Okay. And then we have checked all the previous numbers. Okay. So just to recap, we are remembering symbols. We are remembering numbers. If we have a number preceding a symbol, we have that. If we have a number before a symbol on the next line, we have that. If there's a symbol on the previous line, we have that. And the one that's missing is if there's a symbol immediately followed by a number. Right? Like, where's an example of that? Can find one like this, right? Well, here, I guess that's an example. Yeah, that's the one that's still missing. So I guess number. Wait, where was that? Previous number. Yeah, okay. So we have it. Wait, number symbol. That's after reading a number. No, that's wrong. Wait, that's wrong. Uh-oh. Oh no, what did I do? Oh no, I did the wrong one. Oh Jesus. That one should have been symbol, not number symbol. Oh no. Oh no. Yeah, this one is the one I meant. Uh-oh. Okay. Wait, God, let me get things in order. Right, so if you hit a number and then hit a non-symbol, we compare 13 and jump. And if we hit a... Yeah, I think those... Just need to skip those. Yeah. Oh, we actually... we also need to check for... You know what? Let's factor this one out into a function. Yeah, let's factor this one out. Let's do check function check we call it check previous numbers symbol. Sure. Do that, and let's move all of this into that. This one and up until here. Yeah, okay. So if we right, check our previous numbers on once we had a symbol. Right, so we check through all of those, and if we find one, we count as valid and reset it. Yeah, okay, and we're done, we return. Yeah, okay. And we return, and then here. So if we find a number, we are passing a number, and now we hit a symbol, then we need to still call like previous numbers and symbol. And I guess we jump into where do we jump? Yeah, that's 9. Okay, so we need to remember the symbol. We need to check. I guess, wait, I guess we don't actually need this, we can just check. We can just have an on symbol function. We can just do everything, just share everything we do when we hit a symbol. I think that just makes more sense. So we don't just do that, but we also do the move. And yeah, on symbol. Oops. Do the move, and then we do something where we try the next character. But no. But we don't want to do that one yet. Fuck. Okay. Wait, how do we do that? God, this is kind of getting really tricky. So we have just passed a number, and now we hit a symbol, and then we do all the logic for hitting a symbol after the whole non-symbol thing, right? Yeah. So we do you remember all the non-symbol stuff? And then we do we don't just return, but we do actually take the next character and continue. Yeah, and so we shouldn't actually return here, we should tail call into that one. I think. So I guess it shouldn't. Yeah, it should. So if you didn't know, in assembly, a tail call is just a jump, right? Like the difference between a jump and a call is just that like jump keeps, I mean, yeah, in assembly it's just that call adds a new adds the return pointer to the stack, and jump doesn't. Okay, so wait, if we had this number, do all the non-symbol things. I guess this one is called non-symbol. Where do we jump there even? Seriously, where do we even jump into that one? We don't? What? Number symbol, number. Oh, that one. Number non-symbol. Actually, we jump there, or do we call that one? I guess no, this one should be I guess this one should be number shared. And then we do, it's so messy. Number non-symbol. And this one jumps into non-symbol after calling number shared. Oh geez, that's so messy. Okay, and if we get a non-symbol, we call number shared and continue somehow. I guess jump back to our main loop, I think. Yeah. Here we jump back to our main loop, and here we jump into on symbol. Or we call on symbol, and then jump into our main loop. Yeah, I guess we don't. This one shouldn't resume the main loop, but this one just jump. No, this one can jump back because we need to remember if we need to remember that the next number is gonna be valid. I guess what we can just do is move our 13-1. We can do that. Yeah. Move our 13-1. And then we just, instead of clearing our 13 where do we do that? 13. Right, instead of clearing our 13 here, we actually clear our 13 when we are done. Right, yeah. So if we number shared, this one should clear our 13. Yeah. No, this one shouldn't clear. Should this one clear? Yeah, this one should be clear 13. But no, this one shouldn't. If we hit a number non-symbol, we should clear 13. Because that means the next one we hit is not gonna be a valid part number, right? And we also need to do that on like line and new line and things like that. We also need to clear 13. I think that's it, hopefully. Let's loop end about. Oh, right, if we hit a dot, we just jump back to the loop. Not sure why I did that. Okay, so if we hit a new line, should we colonize the universe or try to stay on Earth forever? Oh, Jesus. I'm just writing assembly, I can't answer questions like that. Colonizing the universe sounds hard. Like, I don't know, do you know how slow the speed of light is? If you wanna get, like, do you know how long it takes to, get to galaxies, get to, like, move even one light year? So, like, I don't know if you can colonize Mars, maybe that's cool. But I don't know. Don't think we're gonna get that much further. Okay, so if we hit a new line, what do we do? Okay, so we have hit our new line. That means we have processed this one. We are done. So we need to swap our buffers. And I think that's it, actually. And reset our line index, obviously. So I guess reset that one. Jump back into the main loop. Column index, I guess. And this one we set our knowledge. I guess it's not like a Pac-Man thing where if there's a symbol here, that one carries over to the next line, right? I don't think it is. Yeah, okay, we set our knowledge about on the next number being valid. And then we need to swap over our buffers. So yeah, so we need to set I guess we need to. Do we need to copy those or can we just swap buffers? I think it's easier if we just swap buffers here. Oh, but then I need to change some things. Yeah, if we just swap those, we need those to be pointers to pointers, pretty much. Yeah. So okay, let's do the other one first. So we're gonna copy everything from current symbols into previous symbols, and clear everything in current symbols. I think we can do that one word at a time. Yeah, we can. Then let's not do 144, 41, but let's do something that's divisible by 8. What's the closest multiple of 8? 146. Wait, what? No, it's not one. Wait, shouldn't that be? Did I mess it up? I guess 144 is better. Yeah. It's 144. Oh, right, it's 3 plus 5, right? It's 8 minus that one. Yeah, okay. That's 144. So we can do like one keyword at a time, I guess. Yeah, we can use IX. We'll loop through IX. We could do like a SIMD doing like 8 registers. Like what's the larger like 512 bits at a time, but I don't want to do that. I don't trust myself enough to do that. Okay, so if we find that Ix is larger than what? Larger than 144. We jump out. And otherwise we keep on copying things. So I guess we just move a keyword from what's it called? From current symbols to AVX, move that one into previous symbols, or not current symbols, but current symbols plus IX. Move that one into previous symbols plus IX. And move 0 into current symbols plus IX. Okay. Right, so we are zeroing out current symbols and copying the current symbols over to previous symbols. Actually, it's symbols. It's not really swapping, right? It's carry symbols. Oh, it's more fitting. And it's a loop. Okay, so we are carrying this over, and that's safe. Oh wait, we need to add ix8, obviously. Okay, and so that's safe, and we're always doing 8 at a time, but that's fine, because yeah, because we because it's a multiple of 8, right? It's 144. Actually, I think if we do this 1 times 8 times, we can use increment here. I don't know if that's more efficient. Let's not do that. Let's click this. Okay, now we need to swap over our other buffers. Those should be really fast, because we can just have like pointers into, like we can just have 2 buffers, right? We can have this one, and we can have this one, and so we are we can just reset the offset, so the size. We can just reset the size of one and just copy those, just swap those between the two every time. And that means that we need previous numbers to be a keyword pointing at buffer 1. Let's put it here. And so it's a pointer to an array. And signal me 0, and that one's going to be a keyword pointing at buffer 2. And now I need to modify everything. Yeah, because that's not going to work. So actually what we need to do is move to RCX, because that one's definitely free. Previous numbers. Then use actually value add previous numbers. And then use RCX here. Okay. With previous numbers. And now we need to do the same with current numbers. Yeah, because that's not gonna work. That one needs to be value inside current numbers, so that's RCX. Yeah, and that should be everything. Hopefully. Yeah, okay. Right, so we're doing that, and then swapping the buffers should be really easy. Actually, we don't even need to loop there. We can just swap the number buffers and reset the current size. Right. So we do move RCX this one current symbols and remove wait, do we need version parameters? I guess we do. Yeah, I mean RDX previous symbols. I'm not using RDX anymore, right? No, I don't think I am. Okay, so RDX previous symbols, RCX current symbols, and then we just swap those. Previous symbols is gonna be CX, and current symbols is gonna be DX, and we'll set the current offset, no, the previous offset to the current offset, which I don't think I'm allowed to do it like that. So carry over the size and the current size previous the current size, right? And then we'll reset that one. Does that work? I guess that's probably doesn't. What comma decorator are in the line expected? Yeah, right. Same one there. And Jesus. Operand size not specified. That's a keyword. I misspelled keyword. Of course it is. Okay, that seems valid. What? Invalid combination of opposites. Oh right, CMove can take an immediate for some reason. Yeah, then I guess. Let's use RBX there. On number EF, I don't have that one defined. I guess I don't even need that one, because like there's a training new line. You know, if there's an end of file, it's not after a number. So I guess on number EF can't even happen. That's nice. And on number new line, I don't think that one. Yeah, no, that one has to behave differently. That one has to be call number shared. Does it have to do anything else? Yeah, it also needs to do reset R13. So on number new line, I guess where do we put that? I guess I'm gonna put it just here. On number new line, it's gonna reset R13 and call actually call number shared first. Does that one reset already? No. Okay, so it's gonna call number shared, then reset. Oh, actually, it needs to do it in this order. Yeah. Then reset R13 and then jump back to the main. No, jump to the new line. Reset thingy. On new line. Oh, and that one resets R13. Okay. So number shared and jump to on new line. And then what are you gonna do? I guess wait, on new line. Yeah, we swap the buffers and do all of the jams. Number shared not defined. What did I call it? Dot number shared. That's why. Okay. There's a jump. It doesn't lead anywhere. Oh, it's already part number. No, that's not. That's not. It's already part number, is it? Oh, I'm getting so lost in my own code here. Yeah, it is. It is. It is. So it's already part number. Right. New keyword RCX MX. Yeah, that doesn't work. So we need an immediate to get temporary in between. Wait, what are we doing here? Current number offset, initial number position. Okay, yeah, no, that's correct. I think, yeah. Add current number offset 3. Oh, keyword. Option size not specified. Ah, that needs to be a byte. Swap done, not defined. Why? Oh, because I got to carry on. That's why. Yeah, and that doesn't work. Weird. So we need temporary. And someone here, I guess. I guess, yeah, I guess we'll move 0 then. If you can't XOR memory location with itself. And keyword. Okay, it's like false. That's better. I guess on EF we just print out the total sum. And that takes an input in IX, yeah. Okay, so where does it stack vote? In read number loop. Where's that? In one of the comparisons. Okay. So what's previous symbols? Wait, that's no, let's do. Wait, what's R14? That's not one, two, three, one. Way too high. Jesus Christ. That's not what R14 should be. Okay, I guess that's the explanation of what went wrong. But why did that happen? Jesus, how does that even happen? Some loop is not ending correctly. Yeah, let's just run from the beginning, I guess. Just step through. Okay, so we are doing what we're setting things up, and then reading 6-4. That's 6-4. That's a dot. Right. I always keep forgetting which one's which. What was it? 46. That's a dot. Yes. Okay. So we read a dot, and then we into our main loop, increment R14. So we are at position 2. Oh, right, we just skipped 1. Yes. So we are at position 2. That's also a dot. We keep going through things. 3, 4, and now the 5th one should be something else. Yeah, 57. That's 9. I'm pretty sure. Yeah, I mean it has to be. Right. So it's not a sum, but wait, where's that? Right, yeah, compare Ix. Right, it's not a symbol. It is a 9, that's correct. So 12 is 9. Move on, where's that? Right, what? Start reading number. Where's that? Yeah, oh, okay. Move initial number position, right. So we remember 14 for later. And that's on position 5. Wait, it did not actually decrement that 1 by 1. I mean, that's not what sec false, but that's wrong. Because if that's on 5, 1, 2, 3, 4, 5. Yeah. Yeah, exactly. 1 based position. Wait, I'm 1 base. Yeah, no, I'm 1 base, that's fine. Position 5, that should save position 4. Yeah. That's not why it's sec false. That's just wrong. Okay, so it was that one. And then what? Read number loop. Right, now it's checking for the previous line, which should not actually do anything. Should not? Yeah, it doesn't. And yeah, we need to read the next character and keep reading numbers. That's what we're doing. Right. Oh, wait, I think I know what I forgot. Oh, actually, that's not the issue, but probably. But yeah, I didn't actually subtract 0, so we didn't actually convert it to a digit. Oops. But that shouldn't be the issue. And that should give a completely wrong result here. Like R12 is 9. Wait, what? Wait, no, that's wrong. What's happening? Okay, that's wrong, but I've changed quite a few things, so let's recompile at least. Increment the byte. Initial number position. Yeah. Not byte, like qword. Okay, so let's break on start reading number. Oh, let's underscore start. Let's start reading number. I guess I'm not even using that label anymore. Okay, so R12 is 9. That's correct. It's remembering 5. Oh, actually, it's remembering 4. That did not do anything. What? Oh, no, it's the wrong one. Yeah, okay. Oh, that's correct. Right, so it's remembering 4. My initial number was at position 5, but remember 4 because remember because of the diagonals. If there's one at position 4, that's also valid. Yeah. Okay, so we move RBX1. We compare the previous one. Yeah, right, the one in the previous line. We check if the one in the previous line was set, and it wasn't. And still wasn't. Okay, so we have read 1 digit. We have read a 9. And yeah, and so we keep reading digits. So we read one more, that's 5. And what just happened? What? Wait, what? Weren't we just jump read number loop? What's happening here? What did I do here? Ah, guess that's wrong. Whoops. Okay. I'm not sure what happened there. Let's just run it to oh, it ran to completion. Oh, okay. Yeah, okay. That might just have been the solution, I guess. Cool. Yeah, then let's try that. Let's see if that was the answer. Let me just switch screens quickly. Is it? It's so weird to see in OBS. Yeah, okay. Nice. So, actually I can copy out of GDB. The answer is 105,628. And see if that's the answer. It's not. It's too low. Okay. Yeah, I kind of figured it was gonna be too low. Okay. So that's too low. Let's see. Okay. What could be going wrong? I guess let's just reproduce some minimal examples because that's probably way easier. Let's see, what if there's a number followed by a dot and nothing else? What if we do that? Wait, that should be 0. Yeah, it is. And there's a number immediately followed by a symbol that should be 9. Okay, that's going wrong. That's good. Okay, so it's on number. It's number symbol. What's going wrong? Right, so that one's calling. Let's debug that. It can just break start and just step through everything. Right, so there's jump start loop. Right, so it is a number. We are currently here. So we remember 14. Decrement, yeah, okay. Numbers, we compare, we check if there was previous one, which there wasn't. Then we read one more. So we are 14 is a 2, because we are at position 2, yes. That's correct. And this one's gonna be a star. Yeah, so this one's gonna be a symbol. 42, that's presumably a star. And then we compare IX to what? That's not a new. What happened there? Oh, it's backslash n's being interpreted as something other than backslash n. I don't know what that is. Wait, how did that even finish? Let's just step through until we get the part again. Yeah, and that's why I didn't want to use those last stream. Because, yeah, if you do backslash n, that's not a new line, that's the characters backslash and n is 2 bytes, I guess. Yes, we are reading a char, we are comparing this with hex A, that's correct. And it's not, so we just keep on going. Compare it with a dot, with a number, and right, yeah. We did hit a symbol, because it's not a number. So we do a number shared, and oh, right, wait, what? I'm stepping through that one, exited. What? How? What? Oh, this one jumps back into loop. This one should return. That's why. Still doesn't work though. Yeah. Okay, so we read one, etc., etc., etc. Then we call it char, and we compare that, and jump to symbol. We jump into number shared. Now we compare R13. We see if we had a number before, but we don't actually care. Wait, number symbol should set R13. Yeah, this one should set R13. I guess that's what's going wrong. Is that the issue? Yeah, it is. Okay, cool. Then let's see if that was the only issue. Or if there's something else going on. That's larger than last time. That's a good sign. So, returned. And submit. That's not the right answer. It's still too low. Okay. So then let's try to enumerate the other kinds of issues we could be having. So right, so we have right. If there's nothing that's gonna be 0, that's obviously gonna work. If there's just star number, that doesn't work. Oh, okay, but number star no works. Okay, the dots in front, that should also work, and we have larger number, that also works. Okay. And what if you have star number? Then what? That's that should jump into symbol. Yeah, that should set R13. That's how everyone should work. So break start, one step through. Okay. So I guess we are put it similar. That one. Yeah. Okay. So we move. Remember the symbol from the next line. Yeah. Okay. We move a 13 1. Yeah. We set a 13. Then we XOR a 13. Oh. Oh, we don't actually. Wait, we don't jump anywhere again. How did any of this. Wait, what the heck? How did any of this even run to completion before? I'm just missing the loop, the jump back into the loop. Okay. Yeah, that extends that. Now that works. Let's try if there's. That one shouldn't be counted twice. No, it isn't. Let's see if there's a symbol on the previous line and a number immediately after. That one's counted. If there's space in between, it's also counted. If there is one here, well, that should work, yeah. This one after still works. And if there are 2 stars, oops, didn't want to proof GB, it also works. And if there's a number followed by a star, that one also works cross diagonals and presumably also for larger numbers. Okay, so it seems to be working. Let's try that on the full input again. I'll just copy it back. Okay, let's try that, and sec faulted. Fuck, okay. Right. Where's that started symbol? What's happening? It's trying to set the symbol, but just presumably overrun. Like R14 was too high, probably? Yeah, way too high. What happened there? Okay, so somehow it skipped a new line. Oh, I'm still. Oh, I know why, right? Do I? Yeah, because of that one. That should be hex A. Actually, it's 10. Yeah. And now it works, and that's much higher than earlier. So, third attempt. Let's see if this works. And it's not the right answer. It's too high. It's too high. Oh, so I'm counting something twice. I'm pretty sure I'm counting something twice. Yeah, almost certainly. Okay, so where could we be counting something twice? Let's just try the obvious thing, I guess. And let's just try surrounding a number with a bunch of stars and see what that gives. 9 to... Oh, that worked. Okay. Let's surround the second number with a bunch of stars. I don't know what that adds up to, so let's maybe use something a bit easier to see. Yeah, those are correct. I don't really know what's happening. Seems correct. Yeah, no, that seems fine. Okay, that's problematic. Okay, so I have no idea where something's going wrong. That's fun. And let's just step through, I guess, and see what happens. Yeah, I guess so. Maybe let's check each line. First one should be that one should. Oh, I guess maybe I'm just overcounting. No, I can't be overcounting something, right? Can I? Maybe. Maybe let's check the first line. So let's break new line. And let's check let's round ones and let's see what's it called? What the sum of that one is. That one's 0. Why are you 0? You shouldn't be 0. Oh, you should be 0 because those haven't been counted quite yet. Okay, so the ones we know about right now are none. Yeah, because there are no symbols on the first line. Okay. So then on the next line, it's still 0. What? No, why are you not jumping to why are you not jumping to what's it called? To on new line. Oh, just new line. What should I call it? Yeah, it is called on new line. Okay, I don't know what that means. On new line. Okay. Right. 1, 6, 9, 7. What should those be? Okay, so we have 309. And we have 191. We have 745. And we have 156. And 891. Then this 93. 495. And that's it. Yeah. That's that's larger than that. What? Okay, so this one should have been counted. This one should have been counted. This one should have been. Should this one, and this one, and this one. Oh, I missed the 3 there. Wait, oh no, that should be plus, not a space. That's why. And this one, and that's it. What do you get? 8913. Yeah, I messed up the plus there. That's 2890. That's still larger. What? Wait, let me get through that again. That one, that one, that one, and this one, and this one. And on this line, 3, 495, and yeah, none of those. I didn't count that one because that's only in the next line. Yeah. Why is that larger? Okay, let's just how are we gonna do that? I guess let's like try to reduce the spaces and I don't know, that's kind of weird. Yeah, let's remove spaces and try to step through, I guess. Now this one should give 289. Oops. Oh, I'm in the wrong process. Wrong terminal, I mean. It should give 169. What? No, that's. Wait, what? 1692. Oh, yeah, no. That's, yeah, second track. That's what it should be. But it's counting something twice, or it's counting incorrectly? So I guess, wait, if I remove this number, that's. Actually, let's remove those first. And let's remove, how, wait, actually, I can just use multiple cursors there, and then the alignment will be correct, hopefully. I think I could remove a few more, but I just want to be safe for now. Okay, so this still gives the same result? Yeah, it does. Okay, that's good. And now I guess I can just incrementally remove numbers and see which one's wrong. Wait, not that one. Yeah, I guess. What? Okay, that's very wrong. That one's not even being counted. Wait, if I do this. Oh, none of those were being counted somehow. That one was. Wait, was it 191? No. Wait. 167, what was it? 167, 1697 minus 191 is not 1584. Okay. Not sure what that's about. What if I replace this one with zeros? Nothing changes. Oh Jesus, something's completely wrong. Okay, let's just we just do numbers. Those, yeah, obviously valid. Oh, okay. Oh, Mr. Yeah, still. Okay, that's an interesting start. Hello. Yeah, we're doing assembly, and I mean, I have a solution. It's just completely wrong at the moment. Yeah. Let's see. There's a lot of debugging involved, mostly. Okay, so let's break start, I guess. Let's just step through. Okay, so where are we? There's a 1. I guess we just actually we can just break on the new line because the first line isn't gonna be any interesting, I guess. Let's just break on new line. Next. No, wait. What's the thing for the next breakpoint in GDB? So like there's next, the next I, and there's break, and there's like how do you run until the next breakpoint? Like skip? No. I don't know. I guess we can just step through into that one. Or step through symbols into that one. Ah, it's missed it. I guess we can just restart. Break. That works. Okay. So we just did a new line. So our total sum should be 0. It is. That's good. And so the next one we read should be the star, presumably. Okay, so we are carrying symbols over. Oh, that's gonna be a lot. Yeah. And now I guess we can just print that those were correct. There were no symbols, so they should both be an empty string, I guess. What's it called? What should we call it? Previous symbols. Char, is it char star? What? No, what? That's weird. Zero. That's oh no, that's correct. I guess a char pointer isn't actually that great for this. Because char ref size 144. Yeah, that's good. Current symbols that should also be 0. Yeah, that's correct. And yeah, then let's go back and guess swapping those shouldn't really do anything, hopefully. Reset of 14 and jump back into our loop. Read 42, that's I think that's it's a 1, right? The star. Yeah, that's a star, obviously that's a star. Right. Yeah, so we read a star. That's good. And started symbol. And symbol. So we remember our symbol. Sorry. And so our current symbols should contain a1 at position 1. That's correct. Yeah, because we're doing 1 based indices because we need to check the diagonal. So we can just, like, if we do one-based indices, we can just always have a 0 here. Yeah, okay, so that's good. We are checking that one. We are setting a 13. Right, because there could be a number afterwards. There isn't, but it could be. And then we are jumping back to the start loop. Why are we doing that? Oh, because we... Wait, where's... Oh, no, oh, we... What's the on symbol? Wait, that's... What am I doing here? Shouldn't I just call on symbol? I think this one... What? Is it just calls on symbol? Do that, nothing happens. Okay, I'm slightly confused. Let's break on started symbol. Let's see what's happening. Okay, so we call on symbol. I guess we step into that. Okay, so we remember our symbol and we keep previous numbers and we loop through and yeah, there should be numbers. That's good. Yeah, okay. And so we see if at the start of our range. Wait, so the first one should be a 1. We shouldn't be on the left of that. So this one should not fire. Yeah, okay. And this one should also not fire. Oh, it does. No, it doesn't. Yes, it does. What? Why did that just fire? Okay, we run. And let's inspect that. So, okay, what is R14 is 1. That's correct. And what's x plus rx plus 1 as a word pointer, because I'm gonna... I think that's gonna be like the C thing, where if you add 1 to a long pointer, it's gonna add 4, right? Or 8. I think. If we do that, yeah, and now I wanna cast that and dereference 0. No, that's not what it should be. Why would you be 0? Okay, let's... I have a feeling that it didn't add the numbers correctly. That might be the issue. Let's see. So what's this is a char pointer. What's buffer 1? Oh no, not just char pointer. So long array of size 600, but I guess I don't need to see that many. Yeah, that's nothing. Buffer 2, that's I don't know if that's correct. No, that's not correct. What even is that number? Oh Jesus. Okay, so it's something's being... Yeah, so my hunch was correct. We are saving the numbers incorrectly. This one should have been 1. No, 0, I think. Yeah. Actually, 0's... Yeah, no, that one should have been 0. What is this current... What's the one? Current numbers? Is that one long pointer? Is that one this buffer 1? What's it, buffer 2? Yeah. Say actually long pointer. No. I guess it means no. If I do buffer 2. Yeah, okay, so it's buffer 2. And yeah, that makes sense. Oh wait, that doesn't make sense. Wait, no, that's completely wrong. Because buffer 2 is the one that has entries. It shouldn't. And buffer 1, wait, the previous one should have entries, and that should be the one I'm looking into. Is it? Roots SCX, previous numbers, yeah. Oh, and but also previous number was offset is wrong. It's 12. That's, yeah, no, that's correct. That's correct actually. But it's times 3, right? And that's 0. Yeah, that's also correct. Okay, so it's somehow saving them correctly or carrying them over incorrectly. So I guess let's break on new lines and see if it's there correct there. So if it's breaking when it's carrying over, or if it's breaking when it's adding the numbers. Yeah, let's run. And what do I do? I don't have no history. Okay, so it's current. No, it's actually yeah. Let's look at current numbers as a long pointer. And let's do dereference. Numbers is a long pointer. Okay. Whoa, that's wrong. It's a long array. That's 100. Yeah, okay. And it's already wrong. Very wrong. Like, incredibly wrong. Okay. Yeah, okay. So that's completely wrong. And that's current numbers. So swapping the buffers didn't do anything, which makes sense because it's just swapping pointers. Because it's the part that saves the numbers that's wrong. Oh, and that explains why some of them were like why it's too large, because some of them were just massive. Like this 3000s, it's way larger than any input. So occasionally it would probably just like get lucky and get one of those. Just get larger. Yeah, so where's the thing? Where's it happening? Number shared. I guess it's number shared that's going wrong. Break. Let's display that one. Actually, let's put it into RGB init. You don't want to have to retype that one every time. So as a long array size 100, current numbers dereference. Oh, current numbers as a long pointer. Dereference. Yeah, exactly. That one. And I can't copy out of GDB. Okay, so let's do that one, and let's also do that for previous numbers, just to be sure. So the George was breaking on number shared. Yeah. Okay. Okie dokie. Right, so that's zeros. It's a bunch of zeros. And where am I? Yeah, okay. So it's not already part number. Yeah, we know that. We remember the offset current numbers. Yeah, it's correct. And then we wait, what? Current numbers offset. All right. And the offset is 0 because we haven't saved anything yet. Yes, that's correct. And the initial number position is 0. Yes, because that's where we are. I don't know if that's correctly saved or anything, but it's correct in this case. and then we save our 14. And we are 0, 2, 0. Why is that one offset by 1? Oh no, we saved RDX, right. We saved RDX and now we saved the current position. Right, so we saved 0 and 2, that's perfect. And now we're saving the number, which is 1. So everything is, up until this point, everything is correct. I guess it's saving the 2, that's wrong. Wait, why am I adding 3? That shouldn't be 3, that should be 3 times 8. And that's the answer. Okay, and that's the answer. And, well, it's not the whole answer, but, yeah, that's an answer. Okay, that's better. So let's break a new line again. And see if that's still, like, weirdly broken. No. Of course I don't want to do that. And it's looking good, so that's 0, 2, and that's 1, yes. That's 4, 6. 4, 2, 6, yeah. And that's 2, yes. And then that's 8 and 10 for 3, and 11 and 13 for 4. Yeah, okay. So those are correct. Guess we're carrying things over. Let's see. That did not. Alright, that's carrying those over. And now I'm swapping the numbers. Or not. What? Let's rerun. Let's break on, what's it called? Okay, done. Let's break here and let's see what's happening. Okay, so this should swap the buffers, but apparently it doesn't. Why are you 0? You should not be 0. How is current? Oh, current symbols. Oh, that's why. And I've just zeroed out current numbers, right? Current symbols, right? That's why. That explains a lot. And now that's, Jesus Christ. Okay. It's not 0 anymore, at least, I guess. Whoa. Let's see that things are still correct here. No, it should be, yeah, so now previous numbers is this one, current numbers is this one, and we do previous number offset, that one is as wrong. One is 96. Never mind. Okay, genuinely expected that one to be correct, at least. How is that one wrong now? How does that even happen? How is that 96? And both are 96, okay. How? How would that happen? Current number of offsets 96. Oh no, wait, 96, it's not correct. No, wait, is it? Yeah. 4 times 3 times 8, right? Yeah, no, that's correct, actually. Never mind. It's just kind of long, but it's correct, I think. Yeah. And now current one's reset. Yeah, okay, so that's actually correct. Okay, so this part is working, and now our total sum should hopefully still be 0. Yes, it is. So we keep looping. So we should go into our symbol thingy. Okay, so we are in dot symbol. Alright, so we remember our yeah, remember this one? Actually, we should probably do add that to GBNet. So Charlie No, I guess not. Yeah, I guess like this. Actually, can we do that as a Boolean array? That might be bigger. Oh no, we can't. All right. See, doesn't have booleans. Forgot about that. The symbols and symbols. Okay. Okay, so we do that, and yeah, the second one is set. That's correct because we're one based. So actually, at index one is set. We're one based. And R13 is set because we just did a symbol, and then we jump. Oh wait. Oh no, I skipped on symbol. Okay, skipped on symbol, but let's see what the sum is like. Actually, let's add that one. Oh Jesus. Okay, so on symbol is breaking something horribly. Okay, let's keep track of total sum as well, and let's break on symbol. Okay, so something really bad is happening here. Where? Okay, so it moves. That's right. Numbers previous. Right, it loops through the previous numbers, and the first one should already be valid. Yeah. So it moves into RDX. What does it move into RDX? Here. 6 plus x plus 16. Yeah, right. The number value. That's 1. That's correct. That's adding that one to our total sum. What? Okay, yeah, so that's good. And then it's resetting those two. Yeah, it's resetting those to 0. Because we want to skip those next time. And then adding 3 times 8. Same one here. Wait, didn't I just fix that one? Why did I do that? Oh no, that's in adding the numbers, right? Yeah, okay. That fix it? Yeah, that fixed it. Okay. Phew, finally, that has been fixed. Anyone think that's gonna work the first time? 5%. Oh, that's too large, I think. Let's try that. And yeah, no, that's not the right answer. Wait, shouldn't that tell me if it's too large or not? Because we've guessed incorrectly 4 times on this puzzle. Please wait 5 minutes for trying again. I'm sorry. Not my fault that it's this hard. Why doesn't it tell me if it's too high or too low? No, it doesn't want people to binary search through. Okay, yeah, so let's enumerate cases, I guess. There's something like this. What about that? That's 10, that's correct. What if we have like symbols on the previous line? Also works. What if we have symbols on the diagonal? Yep, still working. As intended. What if we have numbers sharing the same symbol? That's okay. We have something like this one. That's is that correct? No, wait, that's not. Oh, I'm missing some. I guess it doesn't make a difference. That's correct. Wait, let's use an easy number there. Yeah, that is. Damn it. Wait, no, 1, 2, 3, 4. Yeah, no, that's 10. Okay, so it seems to be working. That's not great. Okay, so I guess let's see if the lines add up again. God, okay, so G one, oh, start dot on that run to there. Now sum is 0 to first time, that's correct. How do you continue until the next breakpoint in GDB? Is it just always continue? Oh, it is. Okay, that explains a lot. Okay, so our total sum is 3, 3, 4, 4. That's wrong. Wait, that's on the second linear line. Yeah, that's wrong. Why is that wrong? I guess this is giving the wrong result again. Should that be? It should be 309 plus 191 plus 75 plus 256 plus 891 plus 3 plus 105. And that's it. Yeah, that's too high. It's just why is that too high? So I guess if I remove this digit, I remove this symbol, it's lower by 209. What should I remove? 309. Wait, is that, did I just... Oh, I just miscalculated that. Yeah, that's 309, that's correct. This one should be 191 lower. Got the math in my head. Yeah, that's good. But this one. Oh. That did not change anything. Okay, so this one's broken. Why are you broken? That's a more interesting question. Oh, and now it's... Oh, wait, no, yeah, I removed all the numbers before, so of course they're not going to do anything. Okay, so now it's just 3. It's not processing 755 for some reason. Why not? Why are you not processing that one? I guess I'm missing on symbol call somewhere, maybe? Because if I remove the 3, it probably works, right? Yeah. Okay. So, time for GDB. See? Yeah, it doesn't call on symbol ever. So I guess it's in... It's a number symbol thing, I think. And that one is calling on symbol. Why are you not... Why are you apparently not calling that? Or is it not even... is it not even hitting number symbol? No, it is. Okay. This one, and then that one exits. Why do you exit? Why does calling number shared exit? Does this one? No, this one returns. What? I'm calling into number shared, I'm not jumping. Yeah. How does that return? Not jumping anywhere, it's just... Oh, it is. It's already a number. Ah, that's why. Okay, no, that makes sense. Then it should return. In that case, it actually works. Okay, so one step closer. See if we run that on the full line again. That's 3, that's way too high. Okay, so this one was wrong, but for a different reason. What if we remove this one? That seems correct, yeah. Wait, actually, let's remove the number here. Oh. Now nothing changes, yeah. And now, rid of this, nothing changes. Get rid of this one, it should go down by 309. Does it? Yeah, it does. Change should go down by 191. Is that that's 191. That's not what? 3 wait, what? 323. That's 3432. That's still not what? Okay. But did it also get this 3 here somehow? Is that what's happening? Yeah, okay. So it's counting the 3 even though there are 2 spaces in between. That's strange. So I don't think I care about those. Yeah, it's counting that one. Though it shouldn't. Because I guess it's not resetting the... Oh, I guess I need to wait, where is it? On number non-symbol, on the regular non-symbol, I guess. Yeah. Can't just jump into loop here. I guess I can, and I can CMOV E. X0, CMOV E, OBX, I guess it's really efficient, right? Yeah. I can just jump to on dot. Dot, and if there's a dot, I'm gonna do what? I'm gonna reset at 13 and then jump back. And no, it doesn't count this one. Okay, perfect. Was that everything? Probably not. Let's see. Oh, that looks good, right? What did I get? 2890. Yeah, that's good. Okay, cool. So let's try the full input. I think 5 minutes should have passed. That's still really high. Let's see, I guess. That's the right answer. Woo! Finally, one gold stick closer to strong snow operations. Okay, let's see what part 2 is. I don't think I'm gonna do it today, and it's like really easy. Okay, part 2. The engineer finds the missing part and installs it in the engine. As the engine springs into life, you jump in the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast, though. Maybe something is still wrong. Fortunately, the gondola has a phone labeled help, so you pick it up and the engineer answers. Before you can explain the situation, she suggests that you look out the window. This sends the engineer, holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. Your missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that's adjacent to exactly 2 part numbers. Oh my god, okay. It's gear ratios, the result of multiplying those 2 numbers together. This time you need to find the gear ratio of every gear and add them up so that the engineer can figure out which gear needs to be replaced. Actually, that's not that bad. No, that's not terrible. Yeah, I just need to focus on the gears instead of the numbers. Okay, so that's not terrible, but I'm not gonna do that one today. I'm gonna do that tomorrow probably. So yeah, that's this opportunity. So let's move back there. Okay. Right, so yeah, we got day 1. I'm gonna do day 2 tomorrow, probably. No guarantees, but probably. And yeah, it was a fun stream. I'll find someone to rate and see you next time. Who can we raid? Who's streaming? CM Griffin. Let's rate them. Thanks. Yeah, I know it's been taking quite some time. We finally got it. Yeah, it was a fun stream. Advent of Code is getting really difficult, but you know. Bye everyone.